Hey, welcome back. So, some physical descriptions now of what we've been talking about and looking at with our formal lecture series in perspective, especially now in terms of how we see. So, you've seen the first lecture. This builds on the second one, and it's mercifully shorter. And it is now some physical examination of the spatial world that we're seeing out here, and also how we see and really quantify it with lines and linear perspective. So you see me standing in front of you, and you're now behind the camera, if you will, to a degree. So you're looking at your vision, and you see me now at the same height that I am. So all you tall people out there now get to see me, get to see the world as if you're a short person at 5'6". All right. So what you're looking at is, you'll notice that the eye line and the horizon line go across and come right across my eye line. Now I'm 5'6", so our actual eye level now is 5 feet 2 inches tall. There's about 4 inches difference from the center of the station point of my forehead right here between my eyes, monocular vision right here, to the very top of my head, which is about right here. There's about 4 inches. I measured it just to make sure. So now the eye level is set with mine at 5 feet 2 inches tall. Okay, so we see eye line and horizon line set. They're one and the same. It's as if we're in 1 point or 2 point perspective. And your center of vision is right down the middle of your head too, as well. Just like, whoops, let me put that across, just like this. There you go. So it's that telescopic looking through X. So let me step out for a second, and then you'll see this. You'll see me here, but just slightly out of the way, okay? You see your eye line, your horizon line, or eye level and horizon line, your center of vision here, right? And then your station point is down in the ground at 5 feet 2 inches, right? And then it connects up with your other station point. That's your two-dimensional station point down below, okay? Now your other station point is coming right to your forehead. So this is one thing I wanted to demonstrate too, in the physical world and not on paper. Now we did those diagrams. You could see that we tried to talk about it with the Darth Vader and the Obi-Wan Kenobi, but now I want to show you physically. So this is going to be kind of weird for a second. Your station point lines up with the center point here that connects with eye level, horizon line, and your center of vision, okay? And it goes down the distance line to your station point down there. But if we flap up that 2D vision up to your station point, watch my finger. It's like a string or a laser line. It's going to come all the way into, I'm not going to poke you in the eye, it's going to come right between your eyes, and there's your station point where my finger touches right there, outwards, okay, to the center point. That's your station point and distance line. Distance line coming, station point right there. Distance line, okay, distance line, center point to your picture plane. This is our picture plane, infinite in all directions, okay? All the way back, distance line back to your station point right there. And then we flap it down, down, down. It goes all the way down. I can't see, the camera can't see it, but it curves around and meets up with your other station point here down below at 5 feet 2 inches tall because of our eye line. Okay? So I will always walk and stay relatively the same at 5 feet. My eye line stays at 5 feet 2 inches tall. And that's part of what we're going to talk about as I go into further illustrations after this video. Okay, so I think we've established that quite nicely. We've got your center vision, your horizon line, your eye level, and this camera is set to 5 feet 2 inches tall. Oh, and by the way, the distance line, the space between the picture plane center point distance and your station point is 48 inches or 4 feet. I don't know what that is in meters, But you can, those of you that don't do the metric system, or excuse me, don't use our system, the old English system, which is about everybody uses the metric system, right? You can just convert that really, really quickly. Okay? All right, so now what I want to do, I've got a couple of boxes over here, or just actually one box. I want to show you what it looks like, what we're seeing in space from 1 point, 2 point, demonstrate a little 3 point of what we're seeing, especially auxiliary, okay? And then I'll move the camera slightly at degrees up and down so we can actually see what a box will look like too as well. Okay, so I've got this box here. Just a simple carton and container, right? 1 point box, and I'm holding it up on the picture plane at your eye level, horizon line level, which is all our eye level. When you're a camera, you're locked in. And notice I can't see further down below, nor can you up. So we're limited in that sense. The camera lens, because it's not a wide angle, which is good because it gets more distorted, we can't see as much. Now with our own vision, we can see more, but remember, outside that cone gets difficult. Now, you can't see the cone in this viewpoint. Why? Because we're in your cone. We're in our cone. All right? Now, the cone ends out here more. Out here more. It ends about, let's see, my hand ends here, about another 12 inches or so with our cone. So that's about a 4-foot cone from a distance line, 4 feet outwards at 60 degrees, 30 degrees, remember, on each side. So that's that before I get there. So here we have a perfect cube, 45-degree cube, right, at your eye line, and you cannot see the top and you cannot see the bottom. You know that, and it can hover in here and in here, and this cube is still, your point of view is still eye line level, even though it's a little bit lower on the horizon line, off of the horizon line somewhat, or your eye line, eye level, right? We still can't see the top or bottom. As I lower it down, you're going to start to see a sliver of that box. You can already start to see the top. And as I go further and further down, right, level, you can see more of it and more of it and more of that. And of course, it goes out of your picture now. So this is about as far as you can see. And we start to see that very top of the box right in through here. And as you go up, that dimension gets slider and really disappears really when it starts to be about right in through there. You really can't see the top anymore, and you certainly can't see the top anymore, and you couldn't see the bottom either. Now, if we raise it above your eye line, okay, now we start to see a bit of the bottom, right? More of the bottom, more of the bottom, more of the bottom there, and so on. And we get to see an even more underneath view of the box. Okay, we're a little limited because of the camera view, and I didn't want to get too far away so that you really couldn't see the box either. So there is some limitations to that. But I'm doing this because I want you to trust and believe and understand, not believe, but know that linear perspective has been proven to tell us how we see, and we can use it as a tool for our own creative devices. Both 1, 2, 3 point perspective. Okay, so let's move the box off now a little bit, further and further and further away, and you can start to see, because the box now is pushed over off of the center point to the left, we can start to see more of the right side of our box, and further, right? And further. And we're starting to get close to being outside of that cone. And notice how these depth points are going back to our 1 point vanishing point, which is right in the middle. Now, I'm pushing it against the picture plane, so it's level. It's parallel to us, right? Distance line coming in, picture plane, perpendicular, parallel, front plane, no perspective here. Flat, square shape. So it's still flat, square shape right here. Or if I bring it out closer to us, now, I have to work harder to keep it level in the camera, but you get the idea. And we start to see more of the right side because we're pushed over to the left. Now, if I raise this up, what starts to happen? We start to see not only the bottom, because now we're off the eye level, but we also see, because we're off, we see off of the center point into the left, we see more of the right side. And I can start to play with it here, push it down here, okay, and then down somewhat. And we can quantify all that, bringing it down further. This view gets slider. We still see the same side, okay? And notice I'm not changing the diminishment, or the size of the box is not changing its scale, because I'm not doing this. I'm not going forward and I'm not going backwards. Now it just did. Once I slide it across the picture plane, or I pick a point, let's say out here, and slide it top to bottom, left and right, we don't change our depth. But when we go backwards and forwards, we need a system that allows us to control that space. This box is about 4 inches by 4 inches by 4 inches. 4 inches tall, 4 inches wide, and 4 inches deep. Okay? Let's bring it now down here and let's see what happens. Now we start to see the top, okay, here. And we see a little bit of the right side. Remember, we're off of the center point and through here. We're off of this right and through there. Here we don't see the top, bottom, left, or right. Here we now see the bottom, right? But because we're looking down on from our elevation, which is 5 feet 2 inches tall now. That's our eye line, which is mine. Remember that. So you get to see the world how I see it. Like Yoda, right? Okay, you get the idea. And then we're going to be pushed off that vanishing point, the center point, enough so you can see, again, the right side. And the more we push it over, the more you see that side. My trick is to keep it level. And then we start to get further outside the cone. The cone ends about, unfortunately my camera couldn't get it. You can see where my finger is. That's really where the end of the cone is. And look how it starts to get even more longer in here, going back to that vanishing point. It's amazing how that does that. It's pretty cool stuff. Let's see it from this side. So I can step out, hopefully out of the way a little bit, so you can see it. You can't see much of the top, just a little bit, but you start to see more of the left side. And then further, here I am over here, okay? And even further, we start to see more of the top and more of, a lot more now of the left side. Why? Because we're pushed over to the right of our center of vision. Our center of vision won't change with this camera because it can't. We can draw different frames, and that's another lesson, but you can't with a camera or a digital recorder. You can't get out of your own center of vision. Now I'll lift it up a little bit. We see the bottom up underneath, right? And we start to see, again, more of the left side. Now if I go diagonal, both of those start to diminish as I come in, diminish further, and they both disappear to a flat, back to a flat square. Why? Because I'm relatively equal distance from our center point, top, bottom, left, and also right. Okay, so I'll just move this around a little bit so you can see further, what we're seeing and why. Pushing it off, we start to see more of the left side, more of the bottom. I hope that's in the camera because I can't get all the way over there. Same thing over here as I move it around, and you can start to play with that. Now we're in 1 point perspective, okay? So that's 1 point perspective. And we understand that because when we see an object like this cube, we know that our eye line and our eyes are connected eye line means your eyes, right? Just like it is here. So that's never going to change. But they're also connected in 1 and 2 point. 1 and 2, how about that piece? They're always connected to the horizon line in 1 point and 2 point perspective. They're glued on there. My eyes are always glued. I can't take them off. If I bend my head down and I bend my head up, they're off the horizon line. The horizon line stays the same, but our degree of which we project our 4 fundamentals changes, so our perspective changes, and that gets into 3-point perspective, okay? But our eyes are always glued here. It's as if you can look around you, but you can't move your head. So my eyes can look up some, and that's what gives us more peripheral vision. We can get in and out. We can't get outside of our cone, right? But we can still see a lot more than what this camera gives us. So if we're looking at each other, I'll come back in through here. I can move my eye up and down, left and right. I'm saying in 1 point perspective or 2 point, okay? But if I move my head, then that changes things. This is 2 point. This is 2 point. My eyes are still connected on the horizon line, but I can move my eyes up and down. So I can move my eyes up and down, right? But I can't move my head. Same thing in 2 point. Or I can swivel on the horizon line. I can swivel on and off. That's 2 point. Okay? Your eyes are still connected to the horizon line, but I can't do this. I can't, this is 3 point. Okay, this is all 3 point. So let's go now to 2 point. Okay? So 2 point perspective is, again, we know that we have 2 vanishing points. One now to the right. Let me get a better view of that box. One now to the right, and of course one now to the left. And this one is roughly right on the center point there, equidistant top and bottom, and left and right, to various degrees. I can tilt that a little bit. And the vanishing points are set 90 degrees from one another to give you a perfect right angle. And we'll tell you why that is later on, and how from your station point you can set 90 degrees, 45 and 45, and get a perfect, draw a perfect cube. Matter of fact, we'll get to that really pretty quickly. Now, I'm going to play around with this in 2 point perspective. I'm going to slide it on the picture plane, which is the wall, and it's the same idea as 1 point, but now as I get lower, right, you start to see the bottom of the box further, right? And you still see the left and right to various degrees of changes. So the box does change when the vanishing points are altered. The right one's further away, now it's closer. And remember, our vanishing points are still on the horizon line because our eyes are locked onto the horizon line. That's what makes it 2 point. 1 point and 2 point are a little bit closer connected in that sense. So I'm going to move this around so you can see what perspective starts to do with your vision here. We see bottom, way up here. Make sure I'm barely in the camera, but you can see that. And I'll bring it down so you can see further. Okay. We'll slide it down so you can see, like so. And again, we go back to 1 point perspective, right? Parallel to us, perpendicular, right? Coming through here, flat, parallel to us, standing out in through here. No perspective here, and all of a sudden we get perspective here. Now, remember, in 1 and 2 point perspective, the verticals stay truly vertical and parallel to one another. They do not converge. Okay? Only in 3 point perspective will they converge to a vertical vanishing point. The only convergence or diminishment that we're getting with 2 point perspective is now a right vanishing point and, of course, a left vanishing point. In this case, they're both on the horizon line, and of course, this object is above us. We see the bottom, and we see the left and the right plane, and the front corner tells us that it's 2-point perspective. Very, very big difference between this form, right, and of course this form. Very big difference. But one similarity, one point, the verticals are true vertical, and the horizontals are truly horizontal, parallel to our eye line and also our left and our right picture plane as well. Okay, top and bottom, left and right, they're vertical. These are true verticals and they stay parallel. Here we have diminishment. Here we have diminishment, depth here and depth here, while the verticals still stay vertical. Okay, all right. I think that's important to realize the difference between 2-point perspective, 2 vanishing points, and in the case of a perfect cube, they'll be at 90 degrees, 45 degrees from each side of your 2-dimensional station point, or yourself, your 3-dimensional station point, which can be represented by your 2D self down below in the ground. All right, so that's 2-point perspective as we come through. Pretty powerful stuff. Now what I want to show you is, before I change the camera on us some, is 3-point auxiliary perspective when forms do not stay so rigidly locked into 1 and 2-point. We see the world that way, especially architecture for the most part, or organization of office furniture, parts of a house. My luxurious office, by the way, when they're locked in, mostly architectural, or desks, file cabinets like I have, and the such, where they're pushed up against walls and they stay true to probably 1 and 2-point perspective unless you change your angle, which is what we're going to do here shortly. But what happens when the forms that we draw get off of 1 and 2-point perspective, right? And they do this. What happens when they do this? Well, what happens is when we start to lock in a tilt, especially in 1 and 2-point, we have, remember rule number 3 and rule number 4 perspective. If this tilts up, right, or downward, we have an incline and a decline. And so our vanishing point that we once had on an incline will change, and these will raise up to the degree that they're converging to. Same thing over here. Up and now over as well. Pretty powerful stuff. Same thing not in 2-point, that's the change, but same thing in 1-point all over. Decline, right, let me get my hand out of the way. Decline, vanishing point, downwards, right, to the degree that the angle of the slope that we have. Now, when that happens, when there's a box tilted, the verticals, or all angles of these boxes, will be converging to vanishing points. They'll be converging to a vertical vanishing point down below somewhere in the ground, and into a left, into a right vanishing point, to the same vanishing points that that the box had when it was an upright 2-point box. So it's like we're doing this on the horizon line, and then we're tilting everything and angling things downward, and then now we have another vertical vanishing point. So even the verticals, like before in 1-point and 2-point, they were parallel and upright, right, 90 degrees. Not anymore. They will converge to a vanishing point somewhere down on the picture plane. So if we lock in this box, we tilt this box in different directions, maybe like this, same thing happens. So we took an upright position and on the horizon line, and all of a sudden the horizon line, our eye line, moves. We move our eye line, and now those vanishing points that we had switch and change, and now we have another vertical degree of right angles. Okay, I just want to show you what we're looking at, that these verticals now are not parallel anymore, but they converge to a vanishing point, which is pretty powerful. Okay, so auxiliary perspective of what happens when this happens. Then we get closer to all kinds of multi-perspective viewpoints where we have we might have a one-point interior, and then we might have furniture that is 2-point, and then you might have, that might be a entertainment hall where there might be a juggler, right? I don't juggle. I do catch, but I don't juggle. So what happens if there's a juggler in town and he's performing an act, and we want to freeze frame that, the hands, etc., and he's standing at he or she's standing at a different angle, so she's a 2-point person from our vision, and they're juggling boxes or whatnot, and we want to freeze all that. Well, these aren't 1-point, they're not 2-point, they're 3-point, and our vision is locked in at the horizon line. These become 3-point auxiliaries. So their vanishing points, both left planes and right planes, and vertical vanishing points, will be far off what we had normatively for our room, perhaps, and maybe where chairs and tables are located in our composition. So we can have 1-point, we can have 2-point, we can have 3-point I'll show you in a moment, and we can also have auxiliary 3-point, which gets pretty wild, which we think it's wild. It's a little harder to set up. That's why I like to just kind of do them naturally, but you have to know what the structure is to understand them better naturally, and why there's no side that's parallel. Top, bottom, left, and right are converging. Okay? So you have to know that before you can draw them, I think, really accurately, but it's not that hard. You'll be able to get it in no time, hopefully. And we have that, but we're still locked in, of course, to our eye line and the horizon line. So what I'm about to show you now is what happens when we start to tilt our head downward at some degree, and upward at degree. Anytime we move off just a little bit, it becomes slight to very severe 3-point perspective, all the way until we get straight up, right? Or here, bald head alert, coming straight down, which is 90 degrees. And that goes back to 1 or 2-point perspective. So 1 and 2-point can be locked in our straight vision like we're seeing now, right? This is 1-point perspective. Or can be 2-point if I swivel my head a little bit in our vision. It's like this, and I swivel, and I swivel. But long as our eyes are locked onto the horizon line, no matter where the box is located. 2-point, 1-point, 2-point, 1-point. 1-point, 2-point, 1-point, 2-point, 1-point, right? 2-point, 1-point, 2-point. I think you get the idea. What happened? We never swiveled our head up and down, just sideways. Even if I come closer, I won't get too close, right? 1-point, 2-point. 1-point, 2-point, 1-point, 2-point, 1-point, right? 2-point, 1-point, 2-point. Okay, that gets annoying, so I'll stop. I think you get the idea. At 0 degrees and 90 degrees, that's 1-point perspective. Okay? Right here's 1 and 2. 1 and 2, right? But when we look straight up, all the way up, from 0 degrees to 1 to 89 is 3 point. But when I look straight up, okay, straight up at this box, it returns flat again. That's 1 point perspective. When I swivel my head, that's 2 point. When I swivel my head looking straight up, that's 2 point. Same thing now when I look down, all the way down to the ground, and I crook my neck, and I see a flat box. 1 point. When I swivel my head, 2 point. 1 point. When it's straight and locked, swivel my head, 2 point. Okay? 0 degrees and 90 degrees, but straight, up or down, is 1 and 2 point. Anywhere in between, from 1 degree to 89 degrees, up and over, this is 3 point. 3 point. 0 degrees, 10, 20, 30, 40, 50, 60, 70, 80, and then back to 1 point at 90. Same thing when I come down. 0, 10, looking down with my head tilted, 10, 20, and look how my eyes are off the horizon line. This is our eye level now, right? This straight line, we move our eye line right here downwards across my eyes. That's our new eye line. The horizon line will not change. Here we're locked on. We're at 1 point, 2 point, right? 1 point, 2 point. 10 degrees, 3 point, 20, 30, 40, 50, 60, 70, 80, back to 90. I'll go back again, 90, all the way down, 80, 70, 60, 50, 40, 30, 20, 10, back to 1 point, or 2 point if I swivel. 1 point, 2 point if I swivel, 3 point swiveled, 3 point, back to 1 point. Now let's go up, 10, 20, 30, 40, 50, 60, 70, 80, 90, 90 swiveled, 2 point, 1 point, 70, 3 point, 3 point swiveled, 3 point swiveled, okay? Auxiliary, keep that in mind. All right, so now what I want to do is start to change our camera, and let's look at some boxes when from our distinctive camera vision, we'll set this at an angle maybe 35 or so degrees looking downward at bird's eye view. When we look down, we're at bird's eye view, and when we look up, we're at worm's eye view. Objects are taller. So if I do profile, okay, here I am at 0, okay, and if I look up, 10, 20, 30, 40, this is all 3 point, 40, 50, 60, 70, 80, 90, coming back to 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Back down to 1 point. Then 1 point, I swivel my head, 2 point, 1 point, swivel my head, 2 point. Pretty powerful stuff. There you go. You saw it in profile. You could see me do it in 3/4. This is 1 point for me, 2 point, 1 point, 2 point, back to 1 point, then up 10, 20, 30, 40, and so on. You get the idea. Now, let's get behind the camera. I'll get you behind the camera at different degrees, and we'll come back and we'll look at boxes and talk about again what happens to these verticals, both in worm's eye and bird's eye. Remember the art now of looking down upon with your head tilted down, or up upon with your head tilted up, as if you're looking at an airplane or you're looking down at your cute little dog or cat. Okay? All right, so let's go to that. Hey there, welcome back. So I noticed your eyes are now a little bit lower, so they're kind of focused on the t-shirt. And what do you notice about where now you're looking at? My eyes, okay, haven't changed. Here's my horizon line, right? Here's our horizon line still right here. Here's my eye line, okay? Here's our elevation at 5 feet 2 inches. You're looking down now, angled about 20 degrees downward. So your head is tilted, while mine is up. So already we have a distinctive contrast between what you're looking at and what I'm looking at. Now we'll talk about what you're looking at behind the camera as if you're looking through your own vision. Now you see a box in slight 3-point perspective. And what you're noticing is, this is 1.3 point, which sounds ironic, but this is 2.3 point, which you're probably more familiar with. You can have 1.3 point when you don't see a left or a right. We just see the verticals converging slightly downward to a vertical vanishing point. Now I have a station point, and I should also say that we move our station point over, and we call it a vertical station point. And what's down below now on our center of vision is a vertical vanishing point. And I'll show you how to set that up at a later date. That'll be fun. Okay? So we're looking down now from bird's eye view. And what you're noticing is that these verticals here, okay, are converging to this vertical vanishing point down below. Your new eye level is probably about right here. There's your new EL, your new eye level. And I'm thinking that's about 20 to 25 degrees looking downward. Because if I say straight, look at the difference from our last section and look where you're looking at. You can barely see my eyes, right? Right in through here I am locked in. You can barely see them now. Head straight, my head's tilted up a little bit. Head straight, okay? Look what happens to that box. This is the point of this, is to physically demonstrate that the verticals now are coming down to a vertical vanishing point down below, and they're converging. They're not straight parallel. Okay? The only one that would be straight is if I locked it on the center line. This corner would be, but these two, they're slight. There's not too much distortion because we're not too far outside the cone. But the further we get outside the cone, hopefully we can still see that, the more distortion in our tilt that we get. We're getting a little bit more tilt in the further out. There we go. We get more tilt back into the vertical vanishing point. Of course, whoops, can't go that far. We really can't go that far at all, actually. We're kind of locked in where these objects are. Okay, so you get the idea. So that, again, we're looking down on. Maybe it's easier to bring it over here too as well. So we're looking down on with your head tilted. The object is still level. It's still on the ground. It's not doing this. That's important to realize. This is a different type of 3-point. That's auxiliary. This object is still straight up level. What has changed again is your viewpoint is tilted down, in this case, about 20 to 25 degrees. These are not straight up anymore. They're slightly angling in. They're very slight. There's not a lot of distortion right now until we get further and further away from and out to the cone. Then we get even more distortion. But it doesn't really take a lot. Okay, we're far inside the cone still in our vision, and that's probably a good thing. I wish I could get further out. But the further we move, and it gets really fast on paper, the further we move outside from our center of vision here, right? These get even more angled. They'll come in further and further and further down to that vertical vanishing point. So the things to remember are we're in bird's eye view looking down about 25 degrees, right? Remember that there's no parallel lines. We're still, our right vanishing point and our left vanishing point are still on the horizon line. That does not change. In auxiliary, it does. But right now, it doesn't change. It's still up there on the horizon line, left and right. What's changing is we have a vertical vanishing point that goes down to a, the verticals go down to that point, so they're not parallel. Okay, now let's go on to a worm's eye view where your head is lower and you're looking up now at objects. Let's see if I can do that. I'm going to have to get a stool. All right, we'll be right back. How you doing? So look what's changed. So you have moved off your eye line, or the horizon line too. This is the horizon line, right? That stays the same. Now you've moved your head up, because you and the camera are one. I'm on a little chair to stand up so you can see me, see most of me from my demo here. And so your head is tilted up, right, about 20 or so degrees. So your new eye line is probably about right here. Okay, it's an educated guess, and I'm thinking that's 20 to 25 degrees head tilt. So you've actually physically moved your head, right, demonstrated by the camera. You're locked into the camera together, so you can't move away from the camera. It's locked in. So we have a head tilt now of about 20 to 25 degrees. This becomes your new eye level, right in through here. Here's the horizon line. It stays the same. The elevation is still 5 feet 2 inches. We didn't get shorter or taller. We just tilted our head up. This is what it looks like. Okay? So the station point is now been moved. Generally, I would move it over to the right, somewhere out here. So I'll put just a little dot. It's a vertical station point in through there, and it can be flapped over and still be where we are, right? Where you are, right through your camera. But it's generally going to be higher now, okay? Up here, actually up in here, connected on eye level, okay? Just keep that in mind. We'll get to that later on. What I want you to do is just kind of see what happens when we have a worm's eye view of forms that are level in 3-point, okay? At about 20 to 25 degrees. Now we're looking up above at, when we're from below, at our box. And so what do you notice is you can't see, you totally cannot see the bottom, right? Excuse me, the top. You totally can't see the top. No way. There's no way you can see that. Okay? We can see underneath it. And the higher it gets, the more extreme it gets. It's as if we were looking up at a skyscraper. So if we were looking, instead of 20 to 25 degrees, we might be looking up at 75, 80, 85 degrees, where it gets really, really extreme. And our head is tilted way, way high. If we were looking at a rocket going up and over, we would see the bottom. So these verticals here, here, and over here that you see, they are not parallel. They're converging, okay? They are converging up to a vertical vanishing point, high, okay? Keep that in mind. They get wider here as they go out towards, connect on the ground, but they go up to a vertical vanishing point higher, so that we get this nice sense of distortion in looking up at. So there are no more parallel lines. We have a left vanishing point on the horizon lines, still locked on the horizon line, your left and right vanishing point. But again, your verticals now are higher up to a vertical vanishing point. And of course, it's my job later on to show you how to set that up and how to get that. So there's your extreme view in worm's eye from below, looking up, where the verticals now are not parallel, but they're diminishing up to a vertical vanishing point. Okay. All right, so there you go. There were your physical descriptions of that which we're trying to capture in the real spatial dimensional world out here, right? So you can see how we can quantify that into a scientific, recognizable system of illusion with diminishment and depth. And of course, we can also measure all that. We can have a ground line, picture on the picture plane, and put measuring points, and we can accurately portray 6-foot figures, 5-foot figures through referencing and diminishing and measurement, and you can be very exact and accurate, but very creative. So to end this physical lecture, I want to make sure that you understand that this process, although very technical, everything in art and drawing and design is technical. Let's be honest, right? But we want to open up creative potential. And so these lectures are ways in which you can unlock new, hopefully for you, new creative potential to be as broad and as bright and as interesting an artist as she or he wants to be. And that's my goal, is to unlock some of this, the mystery of perspective for you. It's out there. There are other great lecturers and professors and artists that teach perspective too. I'm not, by any means, am I the only one. And I have my professorial antecedents, those who taught me, which were very gifted and great professors. And it's my job to give it back and pass it on. And so unlock your potential here and learn the physical structures of perspective. 1, 2-point, 3-point, and 3-point auxiliary when the forms twist and we stay the same. And you'll open up new worlds and new boundaries. And you'll be able to draw better freehand without all the technical structures, because that's what we want almost always, is to just be liberated, but have the structures so well ingrained in our mind that we can whip it out and do whatever it is that we want with our drawing ideas. Okay, thanks, and I'll see you next time. I hope you enjoyed it. Take care. Bye-bye.